All right, FHRP. So FHRP stands for First Hop Redundancy Protocol. All right. What's your first hop? What's another name for first hop? Default gateway. Yes. Default gateway. Pop quiz. What is a router's first hop? Default first hop called? When a router doesn't know where to send something, what does it use? Not default gateway, gateway of last resort, or default route. Is that what we said? Yeah, default route. Same thing. All right, first hop redundancy protocols. So end devices are typically, yeah, they only have one IP address for a default gateway. Could you have multiple routers, each configured with the same, routing protocols, the same adjacent networks? Yes, totally. But you are going to need two numbers inside the host's configuration. At least in Windows, in order to do that, you have to jump through some hoops. It's not easy. So the easiest thing, the most endpoint agnostic solution is to have a single router, one number. But how do you get multiple routers to participate in a single routing entity? There's a couple different ways. But the whole purpose is if a router fails, then the endpoints do not lose internet connectivity. So why do we have everything crossed like this? Why do we have all these redundant links? Isn't that going to cause STP to, do a lot of calculating? Well, if this link goes down or this dies, that layer 3 switch, well, that's a router. Yeah, no, that's a layer 3 switch. We still have a connection this way to multiple routers, okay? That's why we have layers here. We've got the distribution layer, and then I think we have the core network layer, and then we have the core routing layer. There's, depending on where you look and who you ask, and what you're trying to configure, there could be multiple layers. It's all about redundancy. All right. So I know this is a lot of reading, but I'll do it for you. One way to prevent a single point of failure at the default gateway is to implement a virtual router. Yes, absolutely. If your router is virtual, it can be, well, in some cases, it could be a virtual machine. When something's a virtual machine, you can save it to a file. You can save that file in multiple places. You can create snapshots so that you can play around with the configuration like it's a video game. Just go back to the last snapshot if you screw something up. Right? What happens if I save and then do something really bad? And then go back to that save and continue on. That kind of thing. All right. But if it's virtual, that does give the illusion to the hosts of a single router. Okay, so they participate in this virtual router. So they have a virtual IP address that they both share and a single MAC address. A single MAC address. So the hosts have no idea. They're none the wiser. They just talk to a bunch of numbers. The IPv4 address of the virtual router is configured as the default gateway on the workstations. When frames are sent from a host device to the default gateway, hosts use ARP to resolve it as they would with IPv4. The ARP resolution then returns the MAC address of the router, the virtual router. Frames that are sent to the MAC address of the virtual router can then be physically processed by one of the multiple physical routers in the group. All right, but we need a protocol to handle all this, okay? Who is who? Who's in charge? So a redundancy protocol provides a mechanism for determining who's in charge and who is the backup, who takes over when the virtual router fails. So here's a visual graphic. So the standby router, which is, I guess, this guy, the new forwarding router. So this one stopped getting messages through the LAN from that router. So now it says I'm now the leader and it becomes the forwarding router. You know, I mean, this is really no different than, you know, you have that one very dependable employee. Well, when they're out of the office, you have hopefully an equally dependable employee to kind of fill in for their role. Here's your different protocols. So several of these are Cisco proprietary. Well, the only one that's not is VRRP and IRDP, but that's legacy. So we've got hot standby. Hot standby is used in a group of routers selecting an active device and a standby device. The active device is the device that is used for routing packets. The standby device is the device that takes over when the device fails. That kind of implies that there's only two. Two or more. Okay. Yeah. Okay. Guess how many routers VRRP supports? I don't know which version. One of them, it's probably 2, 3, 255 routers. What are the odds if you're having to use your 250th router, 255th router? Not zero. It's not zero. The odds are almost never zero. So slightly different terminology, slightly different ways of pretty much achieving the same thing, which is FHRP, first hop redundancy. All right. So Cisco provides this because they are benevolent and they don't want us to struggle. Nothing is being said here. Election process. So priorities. We have these priorities. So this is one of those cases where it's just kind of raw memorization. Higher number wins in this case. Okay, in other cases, like with STP, we saw that the MAC address, it was lowest number MAC address, right? Yeah, and then lower number port, lower number this, lower number that. This is higher number. Okay, HSRP, higher. There you go. Remember that. So the higher priority wins. By default, it's 100. So if and yes, you should absolutely know what happens when you lose your router on your network. It's like not knowing what's going to happen to your car if you lose a tire. I think we can imagine what happens, but you know exactly what happens at 10 miles an hour, 20, 30, 40, 70. Different, completely different outcomes. Okay. So good news is this is the computer world, so you can virtualize everything and test it out, and you don't have to risk very much at all. So you could set all this up in Packet Tracer if you wanted to, mirroring your real life network, your production network. All right, so if you need to trigger an election because something's hung up and it's not functioning the way you want it to, you can do standby preempt. Yeah, and this, you would do this when you bring your primary router back online. You know, this would be a good reason to keep your older router that you just replaced, unless it's end of service life and a potential hazard for security. With preemption disabled, the router that boots up first will become the active router if there is no other routers online during the election process. So have you ever managed to turn on all your computers at the very same time? Have them boot up to the operating system in the same moment? No. So unless you strategically turn on things on and wait for them to come back up completely to ensure that they win, no, you're gonna have to do the standby preempt command during production. So HSRP states, so similar to Ethernet. So you're probably going to need to know what happens at one of these steps on the exam, I can imagine. In fact, pretty sure. Learn, listen, that's the same. Ending with speak and standby. All right, the active and standby HSRP routers send these hello heartbeats to the HSR group multicast address every 3 seconds by default. The standby router will become active if it does not receive a hello message after 10 seconds. And I'm almost certain you can change these thresholds. Okay, 3 seconds, that's a lot of time for certain organizations. Okay, that's enough for an end user to notice. Oh my gosh. I'm being sarcastic, but like, yeah, that's a big deal. If you're working in a data center and you've got billions of dollars worth of economic activity happening under one roof, yeah, 3 seconds is in the ballpark of millions of dollars all of a sudden. Okay, you don't want to be responsible for that. Yeah. And they probably won't fire you the first time, but only once. Do not set the hello timer below 1 second or the hold timer below 4 seconds. So there you go. There's some best practice. Yeah, because then things are just gonna get out of sync. Okay, and if there's a slight delay in the network, say there's a bunch of traffic, someone starts downloading Call of Duty, that could cause delays, which would cause more delays, and then all of a sudden, no one knows who the leader of the virtual group is. You know, it's got to be a chicken or egg situation, not chicken and egg. All right, that's it. Simple stuff, just conceptual. We're not actually going to implement this physically. I don't even think there's a packet tracer for this. Forget.